Okay, first we're going to talk about the activity that you did the other day. This is not a generic problem. We use X and Y when it's a generic problem. This is a specific problem. And so when you are writing function rules, you should use specific lettering. Like here, this was about the number of blocks, which sometimes I do like to put X and Y here just to remind myself that X always comes before Y. But I'm not using it in the problem. I'm just using it to think about graphing, which is about the x-axis, which is about the y-axis, which one is the independent variable, and which one is the dependent variable. And so here I see that the number of blocks, well, we're talking about blocks, and so B would be a good variable. C for cubes, somebody might have used. And then the next column was about the total number of faces to paint, so I used F for faces. So you need to use specific variables according to whatever's in your chart. If you use X and Y, then I'll have to take points off because X and Y is a generic brand. Table, you should be putting in your table what your table is about. That should be the very first thing. Your table is not always going to be given to you. Here I gave it to you so that you could see an example of what to put in there. But you're going to have to figure out what it is that you're using for your independent variable in the future and what it is for your dependent variable. So if I look at my equation, I see that faces equal 4 times the number of blocks plus 1. A function rule are things that you will see. This is an algebraic equation. It's not an expression. An expression wouldn't have an equal sign. It would just be 4b plus 1. That's an expression. So this is an algebraic equation, but function rule is what you're going to see. So when you see anything like that, you know that they're talking about an equation. You take your equation and you just talk about it using verbal words. Faces equal the product of 4 and b increased by 1. I mean, there's so many different ways that you could say this. You don't have to use what I said. You could have said, actually should have been 4, the faces equal the product of 4 and the number of blocks increased by 1. Where did we get the equation from? Well, usually you have data. We had over here where we tried to figure something out, and then here's the data. That's where you first go to. You should always go to your table first because that's your data. That's what everything else is built off of. So my question to you, if the algebraic equation or the function rule is faces equal 4 times the number of blocks plus 1, where do I see that in the table? I should be able to see that in any of the 4 views of the function. So where do I see that in my table? I should be able to see my function rule in the table. So where would I look? Obviously, faces and blocks, I can tell, are from the headings up top. But what about the 4 and the 1? I should be able to see that. Does anybody see where there's a 4 or a 1? What do you got? On this first one right here? Yeah. There you go. Critical thinking, that's great. That's what math is really, really important, to be able to critically think about mathematics. So if this is a 1, what's the number that goes over in this column then? She also said that she could see plus 4 right here. 1 plus 4 is 5. 5 plus 4 is 9. Correct. How did you know that was going to be a 0? Exactly. Exactly. And so moving forward, being able to see these patterns like this, it's sometimes writing a function rule is not easy. But if you have a table of values and you can see that you have consecutive numbers here, they have to be consecutive, one after another, 0, 1, 2, 3, 4. If they're not consecutive, then you're not going to see this part over here happening. Here, this 4, if you can see that it's changing at a constant rate, it's the same, then that is what's being multiplied to your variable. What happens if it was minus 4? What do you think it would mean if it was minus 4? Nice try. Nice try to think if it was a minus 4, it would be negative. It was increasing, and so what operation was happening over here? Multiplying. So when we see a number is increasing, it's about multiplying. When it's a negative, what kind of things happen to a variable when it's decreasing? Dividing would make it go down. A square root would make it go down. So you're looking at, if your numbers are increasing, then you're thinking about things like multiplying, squaring, adding. And if they're decreasing, then you're thinking about dividing, square root. And then the +1, every time, this is going to be true for every function. You'll see this more in Algebra 2. You are looking for the 0 number when x is 0. And so when I see that 1 right there, when x is 0, it's going to be 1. If it was if this was a -1, then it would just be -1. So because it's a +1, it's +1. And I know you're going to ask me questions about function rules. And this is the page that I'm going to go to as an example. All right, so what is the independent variable? What is the dependent variable? What's the independent variable? Where did you guys come up for that? What's the independent variable, Alex? That would be number of blocks. So that's true. I can't tell. The dependent variable is the total number of faces to paint. I can't tell how many faces there are to paint unless I know how many blocks there are. That's why it's dependent on the x on it. Total number of faces to paint. Now, I know that you didn't understand what a reasonable domain or a reasonable range was, and I just have you go through and do as much as you can on this activity, and then I go through it after. If we would have had more time in class, I would have done it then. What is a reasonable domain? First of all, where do I find my domain numbers, Farmer? Where do I find my domain numbers? True, I find my domain numbers in the x's. So if I look at my domain right here, total number of blocks to paint, I have 0, 1, 2, 3, 4. What would be a reasonable domain based on my data? What do you think it means to be a reasonable domain? 2, 4, 6, and 8. Is that what was in your table? Okay, because I would be looking for whatever data that you have. This is like your evidence. You're being asked questions based on the data, so make sure that you have a reasonable domain would be what would be in your table. I guess what do you got, Alex? 1, 2, 3, 4. I mean, it's not unreasonable that you had those other numbers. That's not the reasonable part about it. But to match your data, you want to make sure that all the questions are matched whatever's in your table. You could have put 2, 4, 6, 8 in your table. That would have been fine. Reasonable would be, is it reasonable to have 0 number of blocks to paint? No, it's not reasonable. Just like it's not reasonable in the range that you would have 0 number of blocks and still have 1 face to paint. That's the only part of the domain range that's not reasonable. The rest it is. But it is always good to have the 0 number in your chart because I know whatever that number is that's with the 0 number is going to be what's being added or subtracted to the function. So then in my domain, reasonable would be 1, 2, 3, 4. And then for the range, it would be 5, 9, 13, 17. If you're thinking about reasonableness, oh, well, wait. So is the graph continuous or discrete? Again, we haven't talked about continuous or discrete. But moving forward, when that question is asked to you, you're going to know where to look. So do you think your graph is continuous or discrete? So did you draw a line then through all your points? Okay, so if you drew a line all the way through your points, that's true. That would be continuous. But let's look and see if it makes sense. If I draw a line through my graph, that graph now says that I would have 1.5 blocks to paint. And then I would have 7 faces or so. I mean, you really can't tell with a fraction in here exactly what it's going to be. But does it make sense that you're going to paint 1.5 blocks? No. So when you draw a line, that means that you're taking all of the x's, all the fractions and decimals that are in between here into consideration. So this is actually a discrete graph because we only had 1 block to paint. Therefore, 5 faces, 2 blocks to paint, therefore 9 faces. So if you drew a line, you need to erase it and just have the points there. So this is a discrete graph because it doesn't make sense to want to paint 1.5 blocks or 1 3/4 of a block. How many faces need to be painted for a 25 cube tower? So it's asking me how many faces. for a 25 cube tower. Well, when you have a function rule, you can use that function rule all the time. And you probably use the function rule without realizing it. You just did it in your head. I have that faces equal 4b plus 1. It's asking about how many faces. And actually, I need to change the wording on this because this should be blocks. But cube and blocks are the same. So I have 25 cubes or blocks. So I would just substitute it in. 4 times 25 plus 1. So 100 plus 1 is the faces would be 101. You have a function rule. It would be good to go back and look at it and use it. If it's too difficult, I mean, this was a pretty basic problem. Now number 4 says, if the tower you paint has 25 faces, how many cubes are in the tower? So this time it says you have 25 faces. So F is not unknown. So I put 25 there. And then I would solve the equation. I wish I could have heard what you guys were doing on this one, how you figured it out. You probably just worked in your chart and said, well, if 17 faces is 4, you probably figured out the next couple of ones and was able to figure it out that way. I've seen students do it that way. But if I solve this, I would subtract 1 from both sides. And then I would divide by 4. And I would get that the blocks for cubes would be 6. Number 5, what does the ordered pair 833 mean? What does the ordered pair 833 mean? Hannah, did you have anything for this one? Exactly. If this is X and this is Y, then that would just be 8 blocks and 33 faces to be painted. Does the ordered pair 1250 belong to this graph? Why or why not? Max, what did you come up with for this one?
I said no, because 12 times 4 plus 1 equals 49, not 50.
So 48, good, equals 49. Yeah, there's your evidence right there. Said no, and then you wrote down why that was not true. Okay, so I will be referring back to this page, especially when it comes to writing a function rule. Some people can come up with a function rule pretty easily, and other times it's difficult. So if you have this pattern on your paper, and you've made a connection to when I see a constant rate of change here, where that number goes and where the 1 is coming from,